Hello, welcome back everyone. In this video we will learn about graphing rational functions. To sketch the graphs of rational functions, we follow the following steps. The first step is to factor. So we factor the numerator and the denominator, and numerator, okay, and denominator. Okay, second step is to find out the intercepts. Okay, so find x-intercept. So x-intercepts by determining the zeros of the numerator. So x-intercepts are nothing but the zeros of numerator, and y-intercepts are nothing but zeros of, and y-intercepts are nothing but the value of the function when x is 0. Okay, so you find the substitute x to be equal to 0 in the rational function and find what happens to the value of y. So x-intercept is nothing but the zeros of the numerator when the whole function is equal to 0, right? That is y is 0. Okay, so the third step is vertical asymptotes. So in the previous video we learned how to find the vertical asymptotes. How did we find it out? Like determining the zeros of the denominator, right? Zeros of denominator. Or you can also see whether using the test values, like using the table of values. So you can also see whether y is tending to negative infinity or positive infinity as the values of x or the input values tend towards the vertical asymptote value from either side, like left side and right side. So those are called test values. So fourth one, horizontal asymptotes. So what did we do with the horizontal asymptotes? We had different steps for that, like if you have the degree of the numerator and the denominator to be equal to 0, the horizontal asymptote was nothing but the leading coefficient of the numerator divided by the leading coefficient of the denominator. And if the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote was y is equal to 0. And if the degree of the numerator is greater than the degree of the denominator, so it means that the function doesn't have any horizontal asymptote, right? So follow the steps in the previous video. Steps in video part 3. Okay, so find out the horizontal asymptotes. Fifth one, sketch the graph. So graph the information provided by the first 4 steps and then plot as many additional points as you need as needed to fill the rest of the graph of the function. Okay, so let us do this. I will take an example. So okay, so final is just sketch the graph. Okay, let us follow these steps and start graphing the function. So I will do example number 6 in your book. It's example number, like it's already solved. I am just explaining this example. I'll do an exercise problem soon after I do this. Okay, so given a rational function r of x is equal to x square minus 4 divided by 2x square plus 2x. So we have to graph this. We are asked to graph this and also state the domain and range. State the domain and range. Okay, so to do that, what is the first step that we learned above? It is nothing but we have to factor both the numerator and the denominator. So what is the factorization of the numerator, it is of the form a square minus b square. So that would give us x minus 4 times x plus 4 divided by, what is the factorization of the denominator? It would be 2 times x times x plus 1, correct? So this is the factorized form of the given function. So next, second step was to find out the intercept. So x-intercept is nothing but the zeros of the numerator. So what is the zeros of the numerator? It is nothing but plus or sorry, it is x minus 2 and x plus 2, sorry. So it is plus or minus 2, correct? So plus or minus 2, how is it? Because when x minus 2 is equal to 0, x will be equal to 2, and x plus 2 is equal to 0, x is equal to negative 2. So this is the x-intercept. So then we have our y-intercept to be that point which, when we substitute x to be equal to 0, what happens to the function? So you can see there is an x value in the denominator. So if you substitute 0, the whole function is undefined, correct? So y-intercept r of 0 is not defined or undefined. So there is no y-intercept for this function. So that means the function doesn't touch y-axis at any other at any point. So it is very clear that it lies completely in one quadrant somewhere. Okay, it is not touching the, it is not moving from one quadrant to the other quadrant. So whatever graphs you have, if you have the combination of curves, all lie in quadrants completely. So they are not from one quadrant to the other. Okay, so next, third step was to find out vertical asymptotes. So how did we find out vertical asymptotes in the previous video? We have to check the zeros of the denominator. So what are the zeros of the denominator? X is equal to 0 is 1 0, right? And x is equal to negative 1 is another 0. So these are the vertical asymptotes. Okay, so but we have to check whether both satisfy the, what is that, the vertical asymptote definition. That is, if we have x tending towards 0 or x tending towards negative 1 on either side, like left side or right side, does y, that is our function, tend towards infinity, plus infinity or negative infinity? We have to do that by taking test values. So we shall do that by a table. So behavior near vertical asymptotes. So what is the behavior? As x tends towards negative 1 minus and negative 1 plus and 0 minus and 0 plus. Okay, so let us write down the sign of y is equal to x plus 2 times x minus 2 divided by x 2x times x plus 1. Okay, so negative 1 minus. So what is negative 1 minus? That is tending towards negative 1 from the left. Okay, so from the left, in the sense we have even negative 2, yeah, very closer after negative 2 and negative 1, any value in between that. So that would give us our numerator, that is this particular term, to be positive and this term to be negative. Okay, and the denominator will have this to be negative, correct? And even this term is also negative. Okay, because the values that we consider is, if this is 0, negative 1 and negative 2, we will consider the values, this the values that lie here. Okay, in between negative 2 and negative 1 for 1 minus. So what happens to 1 plus? It is this way. We consider values that I am marking in blue. Okay, so what happens to that? The signs the signs would be, the numerator factors will carry these signs. So that is positive and negative, and divided by, and the denominator will have negative obviously, and this would be positive because it is greater than something, this term x will have greater than -1. Okay, so yeah, so that is positive. And what happens to 0 minus and 0 plus? 0 minus in the sense I consider values tending towards 0 from left, so that would give me plus and minus and minus. You can choose any test value and check whether the signs that I am writing is right or wrong. And this one, 0 plus will be plus, minus, and the denominator will have plus and plus. Okay, 0 minus 0 plus. Okay, this is -1 plus and -1 minus. Okay, so what happens to y? Y will tend to, so if we have a negative and negative terms, negative signs are more in the first term, so y will tend towards negative infinity in this case. And if we have the same, like negative negative, positive positive, same number of positive signs, same number of negative signs, so each sign will get cancelled. You will just have positive infinity, and even this case repeats in the next case as well, and this would be negative infinity because you have one negative sign and all the three positive sign. Okay, so y will tend towards negative infinity when x tends to -1 minus, and y will tend to positive infinity when x tends to -1 plus. Y will tend to positive infinity when x tends to 0 minus, and y will tend to negative infinity when x tends to 0 plus. Okay, so now let us check what is our horizontal asymptote. Okay, that I am writing it as HA. In the given function we have the degree of the numerator and degree of the denominator to be equal. Therefore the leading coefficient of the numerator divided by leading coefficient of the denominator will be nothing but our horizontal asymptote. So y will be equal to, what is the leading coefficient of the numerator? It is 1. What is the leading coefficient of the denominator? It is 2. So this is our horizontal asymptote. Okay, so now using this information we can graph whatever, adding certain extra values we can graph the function. Okay, so you can see the additional values in the book that is given in a table. Okay, I'll just write this up. This is step number 4 or 5. Yeah, 5. So I'll the additional values considered are 0.9, 0.5, -0.5, -0.45, -0.4, -0.3, and -0.1. Okay, so the y value is calculated. You can use a calculator to calculate this. 7.5 and 7.67 and 8 and 9.3 and 22.17. so those things are plotted on the graph. So I will use a graphing calculator to show you how exactly the graph looks like. So the graph looks like x square minus 4. Okay, so divided by 2x square plus 2x. Okay, so okay, x square minus 4 divided by 2x square plus 2x. Yeah, so the graph yeah, the graph looks somewhat like this. It is similar to the one that you see in the book as well. Okay, so now we have to calculate the domain and the range. You are asked to do that. So domain and range. So domain is nothing but all the permissible values of x, right? So you cannot have the denominator of x to be 0. So you are completely eliminating the zeros of the denominator, that is nothing but 0 and -1. So domain is x such that x not equal to 0 and x not equal to 1. Okay, and we see from the graph that we have the range. You can calculate the range. If we see from the graph, it starts from, okay, yeah, what is the value here? Okay, yeah, I cannot see the point. Okay, now I can see it. It's -0.5 and something, so that was approximately half, right? So x is less than half, or x is greater than x is x is greater than 7 point, sorry, y is great, yeah, x is greater than 7.5. okay, so the range is all those x such that x is less than half or x is greater than 7.5. So now let us you just have to follow these steps to graph it. So I'll give you a quiz problem. You just are applying all those things that you learned till now from all the parts of the video. So you're just applying it and plotting the graph with some additional points. So it is pretty easy. Okay, so to do that, let me give you a quiz problem. So this would be quiz 3.6.3. so this is 3.6.3. so this is the question number 56 of the book. Okay, so please follow the question number 56. What does it say? It asks you to find the intercepts, asymptotes, and sketch the graph of the rational function, and also state the domain and the range. And you can use a graphing calculator to that is a graphing device to confirm your answers, like whatever manual answers that you have found out. So to confirm that, you can use a graphing calculator, just like the way that I did now. Okay, so I'll end this video here. In the next video, we will learn something about common factors of the numerator and the denominator, that we have done it as we were simplifying rational expressions. So let us see how it is being used to find out certain characteristics of the graphs of a rational function. So like where exactly is a hole and things of sort. And we also learn something about slant asymptotes and their end behaviors. So we have learned how about end behaviors in one of the sections of the book. So and we will learn something about slant asymptotes. So slant asymptotes is something which is a line. Okay, so you will learn about that. Like asymptotes are itself lines, but you know just about vertical and horizontal asymptotes, right? So we do not know what happens if the asymptote is oblique. So how to find out an oblique asymptote, like a line which is slant. Okay, so we will learn all that in the next video. See you very soon. Thank you for listening.